Okay, we're going to start section 5.1 today. The section is titled Midsegment Theorem and Coordinate Proof. A midsegment of a triangle is a segment, which it's a piece of a line. Remember what a segment is? A piece of a line. So a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangles. Midpoint's the middle, and a midsegment connects the midpoints of two sides of a triangle. Every triangle has three midsegments, so you have to understand this part to move on. I have a side of a triangle. P is the midpoint. It's the midpoint of segment BC. Okay, N is the midpoint of segment AC, and M is the midpoint of segment AB. So I have all these midpoints. The midsegments connect the midpoints. So MP connects the midsegment between AB and BC. Okay, NP is the midsegment, and MN is a midsegment. Okay, it's important that you need to you learn this new terminology because we're going to use it as we move on. Okay, our first theorem of the chapter. It's the midsegment theorem. So theorem 5.1, the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So if you look, D is the midpoint, E is the midpoint. This is triangle, I believe it's ABC, yep. ABC. So this midsegment is half as long as this third side. So DE is 1/2 of AC, which is written right here. Also, segment DE is parallel to segment AC, written right here. Notice these have segment lines over them because you're talking about the actual segment. These do not because you're talking about the measurement or the length. So this is length DE is 1/2 of length AC. We're going to use this equation a lot, and this is very important to understand. Let's try our first one. Triangles are used for strength in roof trusses. In the diagram, UV, right here, and VW are midsegments of triangle RST. Okay, so we want to find UV and RS. We're going to find the measurements. There's no line over it, so we're trying to find the actual measurement. UV is the midsegment and parallel to RT. So I have UV is parallel to RT. So we know that UV equals 1/2 of RT. So we can say that UV equals 1/2 of 90, which is 45 inches. Okay, we're also supposed to find RS. If we look, RS, that's the side of the triangle, not the midsegment. We know that the midsegment is 57. So VW is 1/2 of RS. Or you could say 2 times VW equals RS, because those would cancel out. So 2 times 57 equals RS. RS equals 114 inches. Pretty simple. Okay, you try. Copy the diagram in example 1, draw and name the third segment. I gave you a clue. UV and VW are given already. So this is our triangle that was given to us. We know that this is a midsegment and this is a midsegment. You have to find the third midsegment. Also, number 2, in example 1, suppose the distance UW is 81. Find VS. Okay, I'm going to erase all that stuff and let you try to figure those out. Please push pause and work it independently. Okay, number 1 is pretty simple. The third midsegment is drawn in there for you, UW. Okay, number 2, suppose the distance UW is 81, find VS. Well, if UW equals 1/2 of ST, then you can say that this segment and this segment and this segment are all equal. So VS is also 81. Okay, in the kaleidoscope image, AE, segment AE, is congruent to segment BE, and segment AD is congruent to segment DC. Okay, show that CB, segment CB, is parallel to segment DE. Okay, so we need to show that those are parallel. What can we say from what's given? Okay, we know that E is the midpoint of AB. We also know that D is the midpoint of AC. Okay, we know they're the midpoint because it's the middle. The sides, the segments on each side are congruent. So it's the middle. Okay, the definition of midpoint, I'm going to read it really quick. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So since we know that DE is the midsegment, my handwriting's terrible. DE is the midsegment. We can say that DE is parallel to the third side, CB, because of the theorem, actually the midsegment theorem. Make sure I labeled that right. Yep, the midsegment theorem. Awesome. Okay, a coordinate proof. A coordinate proof involves placing geometric figures, shapes, in a coordinate plane. When you use variables to represent the coordinates or a figure in a coordinate proof, the results are true for all figures of that type. Basically, coordinate plane, square. Okay, we can say this starts at 0, 0. This is, if we start here and move over, we could say this is, erase. We went over a distance of S and up a distance of 0. That's an S. So that coordinate would be S0. Here we'd say we went 0 in the X direction and S in the Y direction. And here we went over and up, S over, S up. Okay, we're going to use variables for our distances. This one is a little complicated. Once you get the hang of it, it gets easier. So really put your effort in to get the hang of it. Alright, example 3. Place each figure in a coordinate plane in a way that is convenient for finding side lengths. Assign coordinates to each vertex. A rectangle. Okay, again, I'm always going to start this in the origin. 0, 0. Okay, and I'm going to label each vertex. So if we start at 0, 0, I'm going to go over this far, which we're just going to call H. So I went X direction H, in the Y direction I went 0. If I go up, in the X direction I went H, in the Y direction I went K. I don't know why I went H and K, they're just the letters. And I have one more vertex. So in the X direction I'm going 0, and in the Y direction I'm going K. So I assigned letters. Basically this distance is K, and this distance is H. Okay, let's try a scaling triangle. Again, my origin, we always want to put one of the vertexes in the origin. Okay, I'm going to go over, this distance is going to be D, Sounds good. So in the x direction I went D, in the y direction I didn't go anywhere. Okay, this distance, we're going to say this distance is, I don't know, F. And this distance, let's just call it G. So here I went up F over G. And I have all my vertexes labeled. Let's look at the book's drawing, see if it is clearer for you guys. Okay, so it's just better writing. Let H represent the length and K represent the width. So the length and the width. Okay, and then for the triangle, we needed 3 different. So I went D is this distance, then I went up F over G to get here. Maybe if you actually made up some numbers to put in for those letters, it would make better sense. Okay, you try. There's quite a few you tries here. I think there's 3. So we're going to do a lot of pausing. So in example 2, if F is the midpoint of CB, segment CB, what do you know about segment DF? I'm going to push pause and you can mark up your drawing and try to figure it out. Okay, I marked up my drawing. We already knew that all of these were congruent. So what do we know about DF? We can say that DF is a midsegment, and we can also say that DF is parallel to AB. We could also say that DF is, DF is 1/2 the length of AB. 3 things we can say. Okay, number 4. Show another way to place the rectangle in part A of example 3 that is convenient for finding side lengths. Assign new coordinates. I'm going to start this one for you, and then you can assign the coordinates. Okay, coordinate plane, and I'm going to go like this. Okay, it's not drawn very well. Basically, you're going to want to draw it so that that it's placed directly in the center. So go ahead and push pause and finish this problem. I'll redraw it also. Not too difficult. Number 5. Is it possible to find any of the side lengths in part B of example 3 without using the distance formula? Explain. Any of the side lengths. Go for the easiest one. Okay? I'm going to push pause. Like I said, go for the easiest one. The length of that one is D. You are able to find the lengths of the other 2 sides, but you'd have to use the distance formula. One more. A square has vertices given. Find the 4th vertex. Okay, try to sketch a picture, see if it would help you, but I'm going to let you try this on your own. There you go, the 4th vertex. Okay, at this point I'm going to stop and post it, and then we'll start again. Okay, but you have to watch both videos.